Hey everyone, I'm back. So this shorter video is just designed to talk you through the output of either Stata or R and help make sense of the data that we're working on this week for our module 4 demonstration video. So for this week, I chose to stick with the example provided by Garson, which comes from a paper originally from, I think it's like Leadership and Organizational Studies, I think is the field, called the Leadership Quarterly. So this is data taken from the military. And of course, the military is known for having lots of clustering or nesting, right? So you have individual squads that are nested in troops and troops that are nested in units and companies. And I probably got a lot of that terminology wrong, and I apologize. Some of you probably know way better than I do. But the idea is that the smaller groups are nested in larger groups. And so it's actually very well suited to this concept of multi-level modeling, not unlike other organizations, right, where your little group is nested in a larger organization, which might be nested in a nonprofit or a firm or a school or so on and so forth. So this is the actual paper, and if you Google this, you can find the actual paper. It was at the time was pretty novel. In 2002, this was when a lot of these methods really started to get attention, and they've really grown steadily since then. But it was using HLM to study leadership climate. So how people feel about leadership and how it can serve as a moderator of different types of outcomes. So pretty cool paper, but we have a version of the data from Garson. So I thought I would stick with it because of course a lot of his worked examples are really nice as well. So the setup for this data set is sort of as follows. So we have essentially, we have data that are collected from soldiers or from personnel that are nested within their company. So the company being a higher level grouping variable in the military. And so we know, for example, what company, using this company ID, each of the respondents, the individual soldiers, was based in. So that's an important first step. And this example from Garson is looking at this measure of hostility. So sort of resistance to going along with the culture of the company or something like that. I think Garson explains it a little bit more closely in the book, but it's this measure of sort of hostile behavior. And that's our outcome that we're trying to understand. And the predictor that we're looking at here is called task significance, or TSIG. And so the hypothesis here is that as an individual perceives a task as being more important, they are going to be less hostile. So essentially the hypothesis was that there's a negative relationship between task significance and hostility. So if you are a part of a unit where you believe and you individually believe that what you're doing is important, that can have some impact on your hostility to the overall mission or goal. The other thing that we're looking at here is a group level or company level measure of task significance. So this is a cool example of what you can do with multi-level modeling. If you know all the folks that are in the company and you have their individual scores, you can take the mean of those scores and get the group mean of that individual variable at the higher level. And that actually takes on different properties than the measure of the individual behavior, which is pretty wild. So in other words, you can be influenced not only by your own feeling of task significance, but also by, in aggregate, how people feel around you, or the mean level of task significance. And so it's kind of like these, like, what's more important, your beliefs or the beliefs of the group, sort of group norms. A lot of cool concepts can be played out in this kind of a framework. So to use Garson's layout here as a model, So when we build this, we're going to run a null model to start with, which is arrow 1, actually arrow A, not arrow 1. We're going to run a conditional random intercept model. So that's arrow C. So that's the relationship between task significance and hostile. And then we'll also look at the relationship here between task significance at the group level and our outcome. So that's just showing you a little bit what we're looking for here. Okay, so I'm going to talk briefly about the Stata output. I'm going to talk briefly about the R output. The results are identical, which is always cool. I always love that. You get the same sort of results regardless of which software you're looking at. Okay, so my fancy video, I thought they were all going to pop up, but a couple of them popped up early. That's okay. So the code is up here. So we have mixed, hostile, tsig, lead, gtsig, and then the random portion of our equation. So let's slow that down just a second. Mixed is the actual estimation command. So Stata knows that you want to run a multi-level model. Hostile is our outcome. So it's the individual's hostility towards the larger mission. Tsig is task significance at the individual level. Lead is the individual's perception of the quality of leadership. So you can think of this as leadership climate, like, you know, do you feel like your unit commander is effective, that kind of thing. And then we have this interesting variable gtsig. So that is the variable task significance just aggregated up to the company level. So that's at the company level, how significant everyone in the company feels that their task is, okay? So those are all fixed effects. We get slope estimates for all of these, well, for these three, just like we would in regression. And their interpretation is just like you would find in regression. In terms of 1 unit change in X corresponds to a beta unit change in Y. We can have continuous predictors and we can have categorical predictors. So none of that element has changed, and that's where regression is cool. The rules kind of hold a little bit. And then we have the random portion of this equation. So again, this is our pipe operator. Company ID is our clustering variable. So that's the thing we're clustering in. And I can look down here and say, okay, I've got 2,000 soldiers nested within 49 companies. And the companies are between 10 and 99 soldiers in size. The average company is about 40 soldiers, okay? And then a comma, so a colon, and here's where I would add some random slopes if I wanted to. We're not gonna get there yet. And then a comma, and then MLE for using maximum likelihood estimation, okay? So the info up here, this is the preface part of your results. We talked about this last week. This is where we get global fit statistics, we get log likelihood information, information about the numbers of groups. This is the likelihood ratio test as well, although this is going to be a little bit different in this case because we have predictors in this model, so it's not interpreted quite like if we were interpreting just a null model, but it's the same general idea. Okay, and then down here we have underscore const or constant, and that is the intercept. So going back to our notation from the lecture, that is gamma 0, 0. And that is the average hostility score across the entire sample, adjusting for the clustering of soldiers within individual companies. So that average hostility score is a 3.4. I'm not entirely sure what that means. I don't remember the descriptive statistics. I think it's maybe a 1 to 6 scale or something like that. So the average hostility is somewhere around a 3, something like that. I hope it's not a 4, right? That would mean people in general are pretty hostile towards the mission. But that's essentially what that means. That's the average hostility score in the sample. Of course, now though, we would want to run that as a null model to get what the actual mean score is, because now we actually have predictors in the model. We have tsig, lead, and gtsig. So it's not just a clean mean, it's actually a mean when all these things are actually equal to 0. So we don't want to put too much stock in that intercept at this point. Okay, so now if we're looking at our fixed effects, we have an estimate for tsig and an estimate for lead. These are predictors at the soldier level or the individual level. All right, so the more significant a task, so here's the estimate for TSIG, it's minus 0.17. Here's its standard error, it's very significant. Here's its 95% confidence interval. So as the importance of a task increases by 1 point on, think of like a Likert scale, right? Maybe like 0 to 5. So as task significance increases by 1 point, an individual is predicted to be 0.2 points less hostile towards the mission of the group. So it's a negative, it's an inverse relationship. More significance results in less hostility. Sort of how that works, okay? The same thing is true of leadership climate, okay? So as the individual perceives the quality of the leadership to increase by 1 unit, whatever that unit is, again, think some sort of a Likert scale, we would predict their hostility towards the mission to go down by 0.3 units, which is good, right? If you're interested in leadership, quality of leadership here really appears to matter. And another note that all of this is controlling for the other variables in the model. So for example, when we interpret TSIG, that estimate would be when comparing 2 soldiers with the same perceived leadership. So we've adjusted for the perceived leadership. And in the opposite, when we're looking at the slope for leadership, we're comparing 2 people who have the same task significance. So that's what that notion of statistical control is doing, okay? So that part is pretty typical to a multi-level model. But now we're getting a little bit further into the weeds because we have this GT-SIG predictor, which is actually task significance at the whole company, at the company level. And all we've done is we've taken the individual responses and we've aggregated them up by taking the mean within each company. And now we have a group level predictor. And the cool thing is the group level predictor is also very, very significant. So assuming controlling for leadership and task significance at the individual level, right? So we've accounted for all that. If you are in a company with a higher level of task significance, you as an individual are also predicted to be less hostile. So that's like a normative effect or a peer effect, which is really neat, something you can measure with a multi-level model. So this is controlling for the individual responses, right? So we're looking at 2 people who have the same exact responses for these 2 variables, and all we're looking at is the third variable, which is the perception around them, the group significance, which is pretty neat. So that's statistically significant too. So this really shows that not only does your perception of leadership matter or your perception of task significance, but it also really matters about the group. So as the group perceives something to be more important, that has an impact on your individual outcomes as well. So that's pretty cool and pretty interesting, I think. Okay, so the other components that we want to pay attention to here are the random ones. So first, where it says company ID : identity, that is the random component at the company level, the random intercept component at the company level, and it's equal to 0.009 or about 0.01. And then below it we have, and that's equivalent to tau, by the way, in our notation. So this is the estimate for tau, and below it we have the estimate for sigma squared, and that is the variance of the residual individual level variability, and that's equal to 0.86. So as you can see, a lot of the variability that remains is at the individual level. So 0.86 is here, and the company level is pretty small at only 0.01. So the predictors we've included so far have done a nice job of reducing the company level variability, but we still have quite a bit to go at the individual level. All right, Stata folks, so that's a little bit of what that looks like. R folks, this looks very similar. So at the top here, we have sort of the preface for our results. We are running a linear mixed model. We are using the Elmer package, or the Elmer command in the package LME4. The formula that we've specified is here. Hostile is our outcome. T-sig, lead, and GT-sig are our predictors. And this is our random intercept component for company ID. So we're allowing that intercept to vary randomly according to company. Here are our fit statistics: AIC, BIC, log likelihood, deviance, and DF-RESID. So those all are things that we could compare back to our null model or a previous model to see if this model has improved fit. Then we get the estimates of our random effects, and then we get the estimates for our fixed effects. Okay? So let me pop these arrows out. We'll walk through them. Okay, let's look at the random effects first. All right, random effects. First, we have a random component at the company level. That is a random intercept. And that, what we're estimating here is the variability of that intercept. And that's what we call tau. So this line right here is our estimate for tau, and it's equal to 0.009 or 0.01. And below it, we have the estimate of variability at the individual level, and that's equal to 0.87. So this is equivalent to sigma squared, this bottom line here. This line right here is equivalent to tau, okay? And if we look at this, we can see that a lot of the variability has been explained at the company level, and less has been explained at the individual level, just by eyeballing and thinking of the previous models. Okay, so those are our random effects. We have 2,000 soldiers nested within 49 companies. Now we get to the good stuff. Although the random stuff is good, the fixed effects really are what tell our story. So first we have an intercept, which is equal to 3.4. So that is the value of our outcome, which is hostility, when all other predictors in the model are equal to 0. So if someone has 0 T-sig, 0 lead, and 0 GT-sig, we would predict them to have a hostility score of 3.4. And then we get the estimates, which are significant, except for, looks like GT-sig is not, no, actually, all of these are significant because all these T values are well above 2. So we have GT-sig, lead, and T-sig are our 3 predictors. And we have first the estimate for T-sig. So it's negative. And what that means is, as an individual's perception of task significance increases by 1 unit, so think about a Likert scale going from strongly disagree to agree, as you start to perceive something as more significant, we would expect their hostility to decrease towards the mission by 0.2 points, minus 0.2. That's what that means, or 0.17 if we don't want to round. Sorry, yeah. Okay. So as they perceive something as being more significant, a task, they're going to be less hostile towards the mission. Leadership also has a negative relationship to hostility. So as an individual's perception of their leadership, the quality of the leadership that they are receiving increases, we would predict that their hostility will also decrease, which is a good thing. So those are individual level predictors. And keep in mind also the notion of statistical control. So one is sort of controlling for the other. So when they're both in the model together, we have to sort of say, when controlling for task significance, this is the estimate for leadership. This is the estimate for leadership when controlling for task significance. Okay, then we have an estimate for GT-sig. This is the company level. So this is what's happening. We've aggregated it up to the company level. And now we get an estimate for what happens when the average company level task significance changes. So think about this as the normative effect, the effect of your peers, the effect of the climate, the larger organizational climate on an individual. So as your company also has a more positive perception of task significance, as they think that something is more significant, we would expect the hostility of an individual person in that company to also go down. And that's controlling for the individual's perceptions. So this really is the effect of the group on the individual, which is really cool. And can, again, you can ask some really interesting questions about the relationship between those things, which is pretty great. Okay, I think, okay, that's my last slide. Hopefully that was helpful, just really diving deep into the output and spending some time with it. So enjoy and good luck.